Hey, what's up everyone? Nick here at iNVisionPrototypes. Over the past year, we've been sharing our journey of building a fat fendered hot rod, a 1944 coupe. Now, I realize not everyone has the time to watch the whole series, especially if you want to learn about metal shaping or English wheeling. So, in the next 13 minutes, maybe 14, I'm going to give you a crash course in English wheeling so that you can start fabricating your own panels. We're going to keep this short and sweet, get it down to the basics so you can get rolling. First and foremost, get yourself a pair of gloves, leather, rubber-faced. Make sure you have a good grip on that panel and it doesn't slide around your hands. Second, you're going to need an English wheel. That's probably important because that's a topic of this video. If you've bought one, great. If you're thinking about buying one or building one, I built this one. You have to consider a few things. What are you going to be doing with your English wheel? If it's a few small panels over the weekend, one-time thing, you can probably get away with a smaller English wheel. But you have to make sure that the frame is stiff enough so that these wheels compress the metal properly. Because as you turn down the adjuster and the frame separates, it's not going to give you the results you want. Now, this is the upper wheel, this is the lower wheel. We also call these anvils, and their primary function is to compress the metal. When you compress the metal, you create more material, allowing it to grow. Both anvils are usually turned on a lathe. If they're done right, then the runout, the amount that they move up and down this way, will be minimal. If they're cheaper anvils, you'll have a lot more runout, and as you're wheeling your panel, you'll never get a smooth surface. You'll get waves in it because as the wheel turns, it compresses and it comes up, compresses and comes up, and you won't have a uniform stretch. The lower anvil, it has a very slight crown to it, and you use this most of the time when you want to get a nice flat area. Then we have this high crown anvil, and it has a very high crown to it, obviously. Now they have numbers on the side. This is 2 3/8, I believe, but really, don't worry about the numbers at this point. I know you guys want to get wheeling. When it comes to surface finish on your anvils, the more polished it is, the better quality of panel you'll get. Now, there are some guys out there that wheel up panels, especially with aluminum, and the finish is phenomenal. It's amazing what they can do with their English wheel. That's all because their anvils are really highly polished. This polished surface will actually transfer onto your sheet metal panel. If you've watched my videos from time to time, you'll see that I change out this upper anvil. These anvils, the primary function I mentioned is to compress. If I switch it out for a rubber wheel, this will form metal, it'll bend metal. It won't stretch it, it won't shrink it, it just bends it over. And if we use a high crown lower anvil, like this, and as we compress the two, the lower anvil will squeeze into the rubber wheel. Now let's briefly touch on metals. We usually use steel or aluminum depending on the situation. Steel is measured in gauge and aluminum decimal equivalents. American cars are usually around 19 gauge from the 20s, 30s, 40s, even the 50s. In the 60s, it started getting a little bit thinner. And then nowadays, it's all plastic. So you have to match your metal to the metal you're replacing. I'm a very hands-on person and I learned by doing, so let's do. We can shape up this piece of 20 gauge steel, this square piece, kind of square, and see how the metal behaves. Or we can do something that once you're done with it, you'll be proud to hang it up in your garage, your man cave, your living room, bathroom, who knows? Or we can go back to this, and once you're done with it, you can just throw it in the trash. Now, as I've been talking, you're probably looking at this form. You might recognize it has an iconic shape to it, and we're going to use this as an example to wheel up two panels, one more complex than the other. But we're only going to shape half of it. We're going to start off with the side skirt, and this is the paper template that we've developed already. And if you want to see how that's developed, let us know. I've transferred that template onto this piece of 20 gauge material. Most crucial aspect in wheeling is the wheeling zone, where you wheel the panel. If you take the panel and wheel it from one edge to the other edge, you're not going to do anything with the panel. It's going to remain flat because you're giving it a uniform stretch all the way through. What you want to do is you want to trap the metal within a particular area to allow it to grow up. I don't normally do it on panels, but for you guys, I'll draw a line around about 1 inch from the edge, and we're going to stay within that area. We're going to wheel it up with our lowest crown anvil because you want to keep the panel as smooth as possible. If you wheel it through and you create a bunch of tracking marks, meaning ribs in the panel, we'll show you how that happens. It's not going to turn out very well. It's going to just loosely outline. You can use masking tape. Tape around the edge if you want. That works quite well. What we've done, we've just indicated a wheeling zone. Make sure that your panel is very clean. You don't want any grit, any garbage between your upper lower anvils. Give it kind of a medium pressure, not cranking down too much on it. And we're going to start wheeling the panel. Just back and forth. But what we're doing, the contact surface on the lower anvil is about 3/4 of an inch wide. And we're trying to keep those passes as close as possible. And in a moment, you'll see the crown develop. You'll also see the panel get stiffer, because right now it kind of flops this way and that way, it doesn't do much. This is the basics. It just gets you into the rhythm of moving the panel through the wheel. You want to kind of train yourself to maintain a proper motion. You don't want to be pulling down on the panel this way or that way, especially with the low crown anvil. It just gives you the ability to practice something simple. Now, you might be able to see it already, but we'll get it on the table and I'll show you what's happening. And look at that, the panel is staying up on its own. There we have our panel, and it's up there. And when I put the square on here, look at the space. Put a 1/4 inch here, a 1/4 inch over there. And we also have strength to the panel. When I push down, it comes right back up. This is for demonstration purposes. You don't want to ever do this with a panel you're serious about. You're getting impatient and you say, you know what, let's just do this. Just crank it up, right? I'm going to create a bunch of stuff. I think it's enough. Yeah, one more. Let's do it. Let's get adventurous here. Okay, there we go. Look at that. When you looked at it the first time, it was nice and smooth and clean. Now we got ribs and all kinds of stuff going on here. I've made a mess of the panel. Now what? First off, I've overstretched this area, created way more crown than we need, and I've got a whole bunch of wheeling marks that, you don't want that. You can say, oh, flip it upside down and wheel it out that way. It's not gonna happen. You need to fix everything up here by wheeling it at a slight angle to what you wheel it as the first time. But as you can see, I'll show you with the square. Now when we have way too much crown. To bring that down, you stretch the edges that allow the material to run out and the center will drop. And after a few minutes, you see those big creases that we had there? They're almost gone. We can keep going and kind of wash it out. Washing is a term where you have really minimal pressure on the panel, where you can basically slide the panel between the anvils, and you're basically just smoothing. So there's our panel. We had a nice panel, nice progress. I messed it up. We smoothed them out, and because the panel grew up, we took and stretched the edges, allowing the center to come back down. So we're basically back to where we were. That's the first piece of our little puzzle here. So after you get comfortable wheeling a low crown panel out and getting the rhythm of wheeling, you can get into some more advanced stuff like we're going to with this top piece. Depending on the equipment you have available, it'll determine how much you can do with your English wheel. This perimeter edge here, you see how the paper's bunching? That needs to be shrunk to allow all that to come down. See that? But we're going to try and wheel this panel up without doing any shrinking. Not really a good thing because you usually want to shrink and stretch about 50% to maintain a uniform thickness throughout the panel. We need to create more material to have it bulge out. So what we're doing is we're doing the same thing we did here, but in a more extreme case. Now our wheeling zone is going to be from about here all the way up and through to there. This area through here is called the reverse curve. That's a whole different animal. We're going to throw the rubber wheel into the upper position of the English wheel, and we're going to give this blank here some form. We're not stretching anything yet, just bending. As you see, we have a very flat panel in terms of this way, but we have some curvature to it that way. Now that we've broken it, I want to take and kind of open it up a little bit. I want to flatten it back out. A lot of guys will take a high crown anvil, thinking that's the radius they want, about there, match that radius up to that, and start wheeling the panel out. You can do it that way, but it doesn't give you as nice of a result as if you do it this way. You see what I'm doing? I'm using my lowest crown anvil, not the flat one, but the lowest crown, and stretching the wheeling zone in this manner. This gives you a more uniform stretch than if you put a high crown anvil in. I'd end up with a whole bunch of waves around the perimeter of it than if I stretch it out this way. Now I'm not going to go any further down into here because we have to take and bend this in a different manner. So I'm just going to go back up. And you'll see the shine coming up into the panel. That one got quite shiny already. And you have to keep your passes consistent. My wheeling zone ends about 1.25 inches from the edge, and I'm stopping there. And I'm moving over about 1 inch at a time as I'm moving the panel across between the anvils. Again, my pressure is not crazy, about medium. You get to know your wheel. Every wheel is different. If I say use whatever pressure on this one, well, it'll be different than yours. You're going to keep going like this until you stretch enough material up, allowing that top edge, the edge closest to you, down. You can see that we're starting to get some proper shape to it. It's starting to roll over. So let's get impatient, throw a high crown anvil in there, and just stretch the heck out of the center. We're going to get tracking marks. Really, it's not the way you want to do this, but if you want to work them out and spend the time fixing your panel after, we'll do that. Now, the trick behind doing it wrong is to keep the passes as uniform as possible down the length of the panel. Because if you stop part ways, start part ways, you're going to get those waves I was talking about. Even though we got that high crown anvil in there, and the panel is taking on really curved shape, it still doesn't match the anvil. So that isn't what governs the shape of your panel. It's how much stretch you develop in your panel. We have a lot of ripples in here and a lot of tracking marks. If I rub my finger over this, it just bump, 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 bump. You don't want that. One thing you notice here, this edge is diving down. That means that we don't have enough material here. It develops so much stretch outward. If we keep going, we'll create a donut. Donuts. What we have to do here is stretch this area and blend it into here. I'm going to clean this panel up first by going back to my low crown anvil and just fixing this. Now that's going to take me a while. And yes, you can always fix a panel. It just depends how much time you want to spend fixing it. It took a little bit to save this panel after we created all those wheeling marks. As soon as I finish this next pass, we're going to do a little thing called a reverse curve. That's the tail end of that fender. We're going to have the fender sweep back. Now, it doesn't sit up on the buck properly just yet because this area needs to curve out. What we have to do is stretch this leg as well as this leg, and that'll create more material here and here, allowing that to swing out. Crazy, but it works. This is where I change the anvil out to a higher crown anvil. Now I'm just going to come in very gently and stretch that back leg. I've just created more material because it got all ripply. So I'll tighten it up by moving inward towards the crown here. And what we did here, we got to do over here. See, pressure's so light I can just get the sheet in without any trouble. Now, if you get the pressure on the machine, you don't want to be jamming your panel in. If you go in on a diagonal, like this, see how easy it goes in? Like butter. Don't force anything. It's all about finesse. So I just wheeled this out through here, and it's starting to bring it around. See that space between the square and the sheet metal? I need to go a little bit more. I need to come up into this crown just a little bit, blend in. This isn't a comprehensive how-to. If you want that, check out the other videos on 40 Ford, because I talk about a lot of wheeling techniques and a lot of patterns and all that stuff there. Here, this is just a quick Coles Notes in terms of shaping up a panel. Okay, now the front's not sitting exactly where it needs to, but as you can see, we're getting a nice curvature coming down and back. So I just need to clean it up a little bit. Now we gotta be extremely gentle, because if we stretch this area right here, we're gonna undo everything we did by stretching the sides. Nice and gentle. Clean it up. And there we go. We've got our reverse curve. We've got the panel clamped to the buck, and the fitment isn't too bad, but it isn't too great either because we have a lot of material back here. So we have to be able to shrink that down. If you have a kick shrink or a stump, you can do that. If you don't, I'd suggest making a joint in the panel here and making it out of 2 pieces. Then you get to learn how to weld. Now, we can do one of 2 things. We can take and shrink this back edge down and incorporate that into a video on shrinking techniques using the shrinker and the tuck shrinking. Or we can do a bead rolling video and create a bead through here. And that bead will eat up material, allowing that to roll down. So my question to you guys, do you want to see a video on buck development where we go from a 2-dimensional scale drawing to a wireframe buck, which is kind of already done because we have the wireframe? Or did you want to see a bead rolling video to create beads or a bead along the top edge of this panel to fit up into there? And then we can do whatever in here just to kind of dress the panel up and show you what happens when you bead without pre-stretching. So let us know in the comments what you'd like to see. I appreciate you guys watching. I hope this little video helped you understand a little more about English wheeling techniques and what the wheeling machine is capable of doing. We did a lot of stretching and we haven't gone through yet. You can't see through the panel yet, so there's still a little bit of material left. But you preferably not want to stretch a panel that much. You want to shrink, you want to stretch, you want to have a combination of the two. I'd like to wish you and your family a safe and happy holiday. Take care, guys.